The topic for today is component level design, basic design principles. A component is a modular building block for computer software. When an object oriented software engineering approach is taken, component level design focuses on elaboration of problem domain specific classes and definition of refinement of infrastructure classes contained in the requirement model. Four basic design principles are applicable to component level design and have been widely adopted when object-oriented software engineering is applied. You can use these principles as a guide as each software component is developed. In today's video, you will learn the basic design principles of the component level design. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you get notifications for our future videos. The topic for today is component level design, basic design principle. Let us start with the introduction. A component is a modular building block for computer software. And the OMG UML specification defines a component as a modular, deployable, replaceable part of the system that encapsulates implementation and exposes a set of interfaces. That's why the component, it is actually the modular building block, and whenever we make the changes in the component, we can make the changes in the system. That's why it is very important to design the component. The component level design draws on information developed as a part of requirements model and represented as a part of the architectural. So whatever abstractions are derived from the requirement model and represented in the architectural model, they are to be considered when we are designing the component. So when we use the object-oriented software engineering approach, then component level design focuses on elaboration of problem domain specific classes and definition of refinement of infrastructure classes. Whatever requirements, as per the requirements, the problem domain specific classes, they will be taken into consideration. And again, the infrastructure classes contained in the requirement model. It means as per the use cases or the scenarios in the requirement model, we'll have to define the infrastructure classes. So the detailed description of the attributes, operations and interface. So these are the three basic components for the class: attributes, operations and interface. So design details required as for when we are doing the construction activity. So when we do it, we'll have to follow certain principles. So those principles are called as the basic design principles. Let us see the basic design principles. Four basic design principles are applicable to component level design and have been widely adopted when object oriented software engineering is applied. So object oriented software engineering, that means we'll be making use of this. And here when we are applying this principle, we have to create designs which are more amenable or adaptable to change and reduce the propagation of side effects when changes occur. So the classes have to be designed in that way. So you can use these principles as a guide as each software component is. So these principles are the open close principle, that is OCP, then Liskov Substitution Principle, LSP, Dependency Inversion Principle, DIP, and the Interface Segregation Principle, ISP. So let us see these principles in details. The first, the open close principle, OCP. Now the principle says a module or component should be open for extension but closed for. So here the component should be designed in such a way that it is open for extension. That is, when we try to extend the functionality, it should be possible. That means it is open for extension without the need to make internal modification to the component. That means without making the changes in the code or logic, we should be able to extend the component. That is the simplest means. So to do this, you create abstractions that serve as a buffer between functionality that is likely to be extended and the design class itself. That means instead of direct design, you create an abstraction that serves as a buffer between functionality and the class. Let us take example to understand this. Suppose we have a home security system. Let us say safe home security system. So this makes use of the detector class. So the detector class that will check the status of each type of security sensor, and it is likely that the number of sensors will grow. So if the internal processing logic is implemented as a sequence of if then else statements, then addressing a different sensor type, the addition of new sensor type will require additional internal processing. That is nothing but another if then else. So it should not be done in this way, because this is violation of the OCP, open close principle. There should be no need to make the changes in the code. So how it is to be done? Let us see how it can be done. Here you can see in this figure, we accomplish the OCP, open close principle, with the help of the detector class. So this is the detector class, and here we have the interface to the sensors, and then we have the functions read, enable, disable, and test. And these are the different sensors which are presently used. The window or door sensor, opening of window and door, then smoke sensor, motion sensor that will detect the motion, then heat sensor that will detect heat, and the carbon dioxide sensor, CO2 sensor. So these are the sensors which are presently used. Now if we are adding the sensor, then sensor interface, here you can see it presents a consistent view to the detector component. So this is the detector component, and it is presenting this view for each of these sensors. So when we add new type of sensor, there is no change in the required for the detector class component. So again it will see the same thing. There is no change seen by this detector. So if we are doing it the design in this way, the OCP is present. Okay. Then let us go to the next principle, that is the Liskov Substitution Principle, LSP. So what does the principle say? Subclasses should be substitutable for their base classes. So here when we are designing the components that use the base class and the derived class, then if say if we are using the derived class instead of the base class, in that case the base class should continue to function properly. So the LSP demands that class derived from base class must honor an implied contract between the base class and the components that use it. So this term contract is a precondition that must be true before the component uses a base class, and a post condition that should be true after the component uses a base class. That's why we call it as a contract. So when you create derived classes, be sure they conform to the pre and post condition. That's why the subclasses should be substitutable for their base class. So when we are deriving the classes, in case of inheritance, we derive the one class from the base class. So at that time, you have to see that they are derived in such a way that they conform to the pre and post condition. So publicly derived, privately derived. So these are some of the things which we have to consider. So the subclasses should be substitutable for their base. That means even if the component uses a derived class, it will work properly. So that is the LSP principle. Then let us go to the next, dependency inversion principle. So this principle states that depend on abstractions do not depend on concretions. What is the meaning here? See, in the open close principle, we have discussed that abstractions are the place where a design can be extended without great complication. So we have taken the example of the detector class. And when we add the sensor, there was no need to change the design. We have extended the design for that without any complication. So the more component depends on other complete components, the more difficult will be to extend. And if it depends on the abstractions such as the interface, then it will not it will be easy. That's why the principles, dependency inversion principle, says that depend on abstractions, do not depend on concretion. Then let us go to the next principles, the interface segregation principle. So the principle states many client specific interfaces are better than one general purpose interface. So when we are designing the client interfaces, because when it is the client server technology, in case of the client server technology, when many instances in which multiple client components use the operations provided by the server class, then this principle suggests that you should create specialized interfaces to serve each major category of clients. Only those operations that are relevant to a particular category of clients should be specified in the interface for that client, not generalizing. Because if particular category of clients, they are using some particular functionality, then you should provide interface for those functions. And if multiple clients require the same operations, it should be specified in each specialized interface. So when we are specifying it, to be provided in each of the specialized interface. So that is the interface segregation principle. Many client specific are better than one general purpose interface. Because if you make one general purpose interface and give it to specialized clients, unnecessarily they will have different operations which they are not going to use. Then additional packaging principle. Apart from the basic design principles, Martin suggested additional packaging principles that are applicable to component level design. These principles are the release reuse equivalency principles, REP, the common closure principle, CCP, and the common reuse principle, CRP. Let us see the details. The first is the release reuse equivalency principles, REP, and it states that granule of reuse is the granule of release. Let us understand this. See, when classes or components are designed for reuse, so here comes the concept of reusability. In order to understand this, let us take some example. Now you are working in Windows environment. Now if you take different softwares of Windows, such as MS Office, and again in MS Office you have different softwares the Word, Excel, PowerPoint, and so on. Now, if you look at, say, the open dialog box, now it is common for all the software. Similarly, if you take the save dialog box, it is common for all the software. The reason is reusable. So they are making those as component and they are being used in different. So when classes or components are designed for use, so when you are going to use them again, then at that time a contract is established between the developer and the reusable entity, that is the class or component, and the people who will use it. So the developer commits to establish a release control system that supports and maintains older version of the entity while the user slowly upgrade to the most current version. So you might have seen different versions of Windows. They're starting from Windows 95, then Windows 98, then we have Windows XP, then Windows 7, 8, and now 10. So, but it maintains the compatibility with the older version. So that is possible because of this one. So rather than addressing each class individually, it is often advisable to group reusable classes into packages. So when we are making a group of reusable classes, we make them as a package, and we can manage, and the newer versions can be controlled with the help of the packages. So that's why this principle, the granule of reuse is the granule of release. So as the new releases are coming, then with the help of packages we can make it possible. Just change the package number and that will work properly. Then the next principle is common closure principle, CCP. So it states that classes that change together belong together. So when we are packaging the classes should be packed cohesively. That is, when classes are packaged as a part of design, they should address the same functional or behavioral area. For example, if you are trying to package classes related to some arithmetic functions, then they should be packed together. Whereas other functions, you have to make another package like that. So the behavioral area or the functionality, as per the functionality, the packaging should be. So when some characteristics of the area must change, it is likely that only those classes within the package will require. So when we are trying to change characteristics of particular area, then only that package requires mod. So this leads to more effective change control and release management. So that is the common closure. Okay, then let us go to the last principle, the common reuse principle. So it states that classes that aren't reused together should not be grouped together. So it is just extension of the previous principle. So when one or more classes with the package changes, the release number of the package changes. So all other classes or package that rely on the package that has been changed must now update. So in order to say, when we do this, new release is operated without incident. So if classes not grouped cohesively, it is possible that classes with no relationship to other classes within a package is changed. So that will lead to some errors. So this will also increase the unnecessary integration and testing. So for this reason, only that classes are reused together should be included in a package. So classes that are not reused together should not be. That is the common. So with this, we come to the end of this video. If you have any queries, you can contact me on Facebook, Twitter, Gmail, or Instagram. Then if you like the video, press the like button and share with your friends with the help of this icon, and subscribe to our channel Engineering and Technology for. And don't forget to press the bell icon. Liking the video, subscribing to the channel, and pressing the bell icon. These are very important for us because that will inspire us to make more better videos. So kindly, if you like the video, kindly press the like button, and if you want to get notifications for new videos, press the bell icon, subscribe to our channel. So thanks for watching. Have a nice day.